This video series is to accompany the Cisco Netacad Switching, Routing, and Wireless Essentials course. This video covers Module 9, FHRP Concepts. In this video, we're going to look at first hop redundancy protocols and then Hsrp. 9.1 First hop redundancy protocols. Now, default gateways have some limitations. End devices are typically configured with a single default gateway IPv4 address, and if the default gateway router interface fails, LAN hosts lose outside LAN connectivity. This also occurs if it's a redundant router or a layer 3 switch that could serve as a default gateway exists. So first hop redundancy protocols, or FHRPs, are mechanisms that provide alternate default gateways in switched networks where two or more routers are connected to the same VLANs. So one way to prevent a single point of failure at the default gateway is to implement a virtual router. To implement this type of router redundancy, multiple routers are configured to work together to present the illusion of a single router to the host on the LAN. So by sharing an IP address and a MAC address, two or more routers can act as a single virtual router. Now, the IPv4 address of the virtual router is configured as the default gateway for the workstations on a specific IPv4 segment. And then when frames are sent from host devices to the default gateway, the host uses ARP, or an ARP, to resolve the MAC address that is associated with the IPv4 address on the default gateway. The ARP resolution returns the MAC address of the virtual router, and then frames that are sent to the MAC address of the virtual router can then be physically processed by the currently active router within the virtual router group. And a protocol is used to identify two or more routers as the devices that are responsible for processing frames that are sent to the MAC or the IP address of a single virtual router. And host devices send traffic to the address of the virtual router, and the physical router that forwards this traffic is transparent to the host devices. Also, a redundancy protocol provides the mechanism for determining which router should take the active role in forwarding traffic. It also determines when the forwarding role must be taken over by a standby router, and the transition from one forward router to another is transparent to the end devices. They just don't see that there's multiple routers. They only see the virtual router. And the ability of a network to dynamically recover from a failure of a device acting as a default gateway is known as first hop redundancy, or FHRP. So the steps for a router failover: when the active router fails, the redundancy protocol transitions to the standby router of the new active router role, as shown in the figure on the right here. These are the steps that take place. There's 3 of them. The standby router stops seeing hello messages from the forwarding router. The standby router then assumes the role of the forwarding router. And then because the new forwarding router assumes the v4 and MAC addresses of the virtual router, the host devices see no disruption in the service. Here are some options. You have the Hot Standby Router Protocol, or Hsrp. That is a Cisco proprietary protocol. It's designed to allow for transparent failover of the first hop IPv4 device. Hsrp is used in a group of routers for selecting an active device and a standby device. Then you have Hsrp for IPv6. That's also a Cisco proprietary protocol that provides the same functionality as Hsrp, but in the v6 environment. And then you have Virtual Router Redundancy Protocol version 2, or VRRP v2. That's a non-proprietary election protocol that assigns responsibility for one or more virtual routers to the VRRP router on an IPv4 LAN. And then you have VRRP v3 that provides the capability to support v4 and v6 addresses. And then you have the GLBP, the Gateway Load Balancing Protocol. That's a Cisco, that is also a Cisco proprietary FHRP. It protects data traffic from a failed router or circuit, like Hsrp or VRRP, while also allowing for load balancing. And then you have GLBP for IPv6. And then you have ICMP, Router Discovery Protocol, or the IRDP. That's specified in RFC 1256. It's a legacy protocol. It allows for v4 hosts to locate routers that provide v4 connectivity to other non-local IP networks. 9.2 Hsrp. Now, the overview for Hsrp: Cisco provides Hsrp and Hsrp for IPv6 as a way to avoid losing outside network if a default router fails. It is a Cisco proprietary protocol. It's designed to allow for transparent failover. It also ensures high network availability by providing first-hop routing redundancy for IP host. Hsrp is used in a group of routers for selecting an active device and a standby device. So in a group of device interfaces, the active device is the device that's used for routing packets, and the standby device is the device that takes over when the active device fails. Now in priority and preemption, the role of the active and standby routers is determined during the Hsrp election process. So by default, the router with the numerically highest v4 address is elected as the active router. However, though, it's always better to control how your network will operate under normal conditions rather than leaving it to chance or leaving it up to the protocols to select. So Hsrp priority can be used to determine the active router. The router with the highest Hsrp will become the active router, but by default, the priority is 100. And if these priorities are equal, the router will numerically choose the highest v4 address. And to configure a router to be active, use the standby priority command, and the range for Hsrp priority is 0 to 255. Now, by default, after a router becomes the active router, it will remain the active router even if another router comes online with a higher Hsrp priority. So to force that election process, you can do the standby preempt interface command, and that preemption is the ability of an Hsrp router to trigger the re-election process. So kind of like a vote of no confidence. And then it goes back through the process, and then the active router with the highest priority gets selected. And then preemption only allows a router to become the active router if it has a higher priority. So a router enabled for preemption with an equal priority but a higher v4 address will not preempt an active router. So you want to refer to the topology in the figure over here on the right to see that. And the note here is that with preemption disabled, the router that boots up first will become the active router if there are no other routers online during the election process, and then the routers after that will not, or they will take the standby role. This chart here shows the states and times. You have the initial. The state is entered through a configuration change. You have the learn state, the listen state, the speak state, and the standby state. And the active and standby routers send hello packets to the group multicast address every 3 seconds by default. And the standby router will become active if it does not receive a hello message from the active router after 10 seconds. And you can lower these timer settings to speed up the failover for preemption. And to avoid increased CPU usage, though, and unnecessary standby state changes, don't set the hello timer below 1 second or the hold timer below 4 seconds. So what did we learn in this module? Hopefully you learned about FHRP, and this is slide 1. And continuing on, this is slide 2.